Welcome all. From this presentation onwards, we will study a new subject, that is sorting. What is sorting in data structure? Actually, sorting is the process of arranging a list of elements in a particular order, that is ascending or descending. But before exploring the various forms of sorting in data structure, let's first look at why sorting in data structure is important. Sorting in data structure and algorithm actually provides users with several benefits. For example, when you are performing sorting on elements, many complications such as minimum, maximum, smallest, largest get automatically simplified. Furthermore, sorting also provides you with many solutions, some of which might include divide, recursive, or best. Last but not least, perhaps one of the biggest benefits of sorting in data structure and algorithm is time complexity. As a coder, the ultimate goal is to solve any kind of complex problem within the minimum amount of time. That is where different types of sorting in data structure come into play. It not only saves up your very precious time, but also provides you with the right solution. So there are two categories find out in sorting. First one is internal sorting. If the input data is such that it can be adjusted in the main memory at once, it is called internal sorting. And another one is external sorting. If the input data is such that it cannot be adjusted in the memory entirely at once, it needs to be sorted. It needs to be stored in a hard disk, floppy disk, or any other storage device. This is called the external sorting. With that said, now let us take a look at different sorting techniques in data structure: insertion sort, selection sort, bubble sort, heap sort, and merge sort. First one is insertion sort. In insertion sort, algorithm arranges a list of elements in a particular order. In insertion sort algorithm, every iteration, here iteration is when the same procedure is repeated multiple times, moves an element from unsorted portion to sorted portion until all the elements are sorted in the list. But insertion sort falls under one of the most popular sorting types in data structure. It is basically an algorithm that helps to place an unsorted element as its suitable position in each iterations. It's similar to the way you sort your cards during a card game. The first card is usually considered to be already sorted, and the next card that you pick up is then compared against the first one. Based on the first card, you whether place the unsorted second card on the right or left side of the former one. The insertion sort follows the same approach like playing a game card into the sorting methods. Let us saw the example of insertion sort. Consider the following unsorted list of elements. These are the elements, and eight elements are available into the list: 15, 20, 10, 30, 50, 18, 5, and 45. Means the unequal here, unequal the 8. So in insertion sort, actually, two sublists are there. First sublist is called the sorted sublist, and second sublist is called the unsorted. Our whole n elements is in the form of unsorted at the first stage. Now let us see. The sorted portion of the list empty, and all elements in the list are in unsorted portion of the list as shown in the figure, right? So second one, move the first element 15 from the unsorted portion to sorted portion of the list. To move element 20 from unsorted to sorted portion, compare 20 with 15 and insert it at correct position. In the third step, fourth step one, to move element 10 from unsorted to sorted portion, compare 10 with 20 and it is smaller to swap. Then compare 10 with 15 again, smaller and swap. And 10 is insert at the correct position in sorted position of the list. To move element 30 from unsorted to sorted portion, compare 30 with 20, 15 and 10 and it is larger than all these. So 30 is directly inserted at the last position in sorted position of the list. To move the 50 from unsorted to sorted position, compare 50 with 30, 20, 15 and the 10, right? it is a larger than all these. So 50 is directly inserted at the last position in sorted portion of the list. So to move elements 18 from unsorted to sorted the list, right? Compare 18 with 30, 20, and 15. Since 18 is larger than 15, so move 20, 30, and 50 one position to the right side in the list and insert 18 after 15 in the sorted position. Next one is to move element 5 from unsorted to sorted portion. Compare with 50, 30, 20, 18, 15, and 10. Since 5 is smaller than all these elements, so move 10, 15, 18, 20, 30, and 50 one position to the right side in the list and insert 5 at the first position in the sorted list. So next one, to move element 45 from unsorted to sorted position, compare 45 with 50 and 30. Since 45 is larger than 30, so move 51 position to the right in the list and insert 45 after 30 in the sorted list. So in the last phase, we can saw that sorted portion of the list has become empty. So we stop the process and the final sorted list of elements is as follows, like 5, 10, 15, 18, 20, 30, 45, and 50. Here we can say that the complexity of the insertion sort algorithm will be increased, means to sort an unsorted list with n number of elements, we need to make 1 plus 2 plus 3 plus dash 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 and minus 1, or number of comparisons in the worst case. If the list is already sorted, then it requires n number of comparisons, means the in the phase first, the sorted sublist will be empty, but at the end of the insertion sort, we can saw that unsorted sublist will be empty. Hope so you can understand through this. Now let us moving forward. So the algorithm regarding the insertion sort. It is performed using the following steps. But before that, we can consider the first element in the list is in sorted portion and all the remaining elements are in unsorted portion. Take the first element from the unsorted portion and insert that element into the sorted portion in the order specified. Repeat the above process until all the elements from the unsorted portion are moved into the sorted portion. Following are the same steps of algorithm. First one is for I equal 1 to n minus 1. Step number 2, set temp. Temp is a temporary variable which is assigned with the array of I. Step number 3, set j assigned to the I minus 1. Step number 4, while temp is less than equal array of j, and after that set array of j plus 1 assigned to the array of j. Set j assigned to j minus 1. Step number 5, set array assigned to the j plus 1 assigned to the temp. Step number 6 is the end. Means at the end of the step, we can saw the unsorted sublist converted into the sorted portion. Right? Let us see the example, means the implementation of insertion sort algorithm using the C programming. So let us start the C programming code into the insertion sort, right? Insertion sort hash include stdio dot h hash include conio dot h main function, opening of the curly bracket. Here we can declare some of the variables like integer, size, I. Another loop we can use for the j. Temp is a variable which stores the temporary value from the list of 100 elements. Next one, clear screen. This function is used to clear the screen. After that, printf, enter the size of list. Then the input elements, that is t, and the variable is used for size. Next one, printf, enter integer value, means integer values. Which values we can input? That one is the size. First one, we can use the first loop. That one is, therefore, we can use the I variable, I equals 0, I less than size, and I plus plus, scanner for input section, modulus D, input section, list of I, mean the each and every element from the list. Here, temp is a temporary variable which is assigned, right? Which is assigned or a scanner, right? Now here we can use the next logic for the insertion sort logic. That one is the for I equal 1, I less than size, I plus plus, right? Here, temp is a temporary variable which stores the value of temp assigned list of I and the another value j assign the I minus 1, right? Now, logic is here. While the temp variable is whenever list means the less than list of j, logically, and j is greater than equal to 0, right? So what happened? List of j plus 1 assigned to the list of j. Now here j assigned to the j plus 1 as per algorithm. Now here close the first control of while loop. Next one, the list of j plus 1 assigned to the temp, right? And closing the control of the for loop. Now at the last, we can print the whole list, which is sorted from the insertion sort. List after sorting is, right, for I equals 0, I less than size, and I plus plus, print f, modulus D, comma, list of I, the elements from the list of array, get ch, and close the program. Here we can save the program, insertion dot c, right? After that, run the program. 5, 23, 56, 44, 11. Meanwhile, the value is maybe 40, right?